handsome dude.
Thank you.
Stock photography?
No, that was a headshot, amateur
Really
taken, of
good,
course.
huh?
All right, so a little bit about myself before I get started. I run a solo consulting firm. I focus on embedded software development for medical devices. I've got 17 years in safety critical industries. My degrees are actually in mechanical engineering, but I did a stint, kind of moved to the dark side and became an embedded software developer. Did a stint in aerospace and automotive, and then I've had the last 8 years exclusively focused on medical devices. And I kind of offer 3 different levels of services with my business. One is kind of an advisory role where I'm your software expertise on demand, for one-off calls or a flat monthly fee. I offer software team coaching and process improvement for companies that have software teams and just feel like they need to improve their processes and get better. And I also offer custom software development if you have mechanical and electrical taken care of, but you need help on the software side. But I focus, my software development is exclusively focused on the device, not on cloud or mobile, that kind of thing. If you need cloud connectivity, I'm going to refer you to Jose. All right, so a couple of different things I want to cover today. One, talking about how software is very easy to underestimate. This seems to be a constant problem. I'm going to try to share my thoughts on why that is, talk a little bit about software risk analysis, and then I'm going to bring up the word that Michelle hates, which is Agile, and talk about some of the problems I've seen with how people think they're implementing Agile, and the risk of mixed typing and development activities, and then one to use modern tools and stop using Word and Excel. So again, I'm hoping this is going to be less than a half hour, and then we can have some good Q&A. All righty. So I think everyone who's been involved in a project that contains software can relate to this, that estimating and especially assessing status of software is just hard. And I think one of the reasons for that is software makes it easy to look complete without being anywhere near complete. It is prototyping in software, the iteration times are so much faster that you can often get to sort of the happy path of the operation of a device very, very quickly. And all of the unseen work to do error handling and error and risk mitigation and all the different corner cases, that's just not nearly as visible. And software engineers usually know this if they're experienced, but they often have a very hard time conveying that in a way that people who are managing projects can understand. And so what you'll see, kind of the symptoms of this problem, again, that you all may have seen before, is the device gets to kind of a basic functionality, and sometimes even very quickly. And the management team is saying, yes, this is wonderful. We're making such rapid progress. And you have these stand-up meetings where people say, oh, I'm 75% done. I'm 85% done with this particular task. And what I see over and over is that status reaches 90% and then stays there forever. And it just never seems to increase. And then the list of tasks seems to keep growing at every single meeting. You're like, oh, well, we discovered that we need to do this. Well, we discovered that we need to do that. And as a result, project managers and management, they don't have any confidence in a completion date. And I'm going to get into some subtleties of this solution when I start talking about Agile, but I think the problem is that software engineers really, really hate doing detailed requirements and detailed design. And I think that's one of the solutions to this problem is people often leave requirements when they're doing requirements. They will leave a lot of to be determined, a lot of TBDs, a lot of said, oh, we'll figure out that later. And there's really no reason to. Most often, if you say, a device must do this, kind of a high level requirement of information to really drill down and think about all the implications of that feature request, that requirement, and really do a detailed design and think through it on paper rather than thinking through it on code. So this is not be advocating for the really, really overweight waterfall approach necessarily, but you need to distinguish when you actually don't have enough information to determine a set of requirements versus you have enough information and you're just being lazy or procrastinating. And so investing more time in detailing requirements to a completion that's appropriate for a medical device, I think is absolutely key to this. And then as you're tracking the status of the software development effort, you essentially track, there's not a one-to-one mapping between requirements and tasks to be done. It's usually a many-to-many mapping. And people start tracking tasks and they don't really track the requirements. And so having both of those methods of tracking all throughout the development of a project, and making sure that when people say they're 75% or 90%, 100% means it's been reviewed, it's been iterated on, it's been documented, it's been tested. Those tests have been incorporated into your whatever automated testing you have. That's done. Joe, you look like you might have a question. Yes.
Not so much a question, a statement, and an invitation. I suspect that what you're talking about has affected almost everyone on the call at some point or another. And
yes,
you seem to be describing in an ideal world. When is it ever? I mean, it sounds to me as though you're saying, let's not do the other stuff until we really do the first stuff. Let's get all the technical requirements and make sure everything's buttoned up so that we can do this properly. Yes, that sounds ideal, Jeff. But there's time that I'm gonna, can't you start doing this while I'm doing that kind of thing? I'm sure that tension happens all the time. So have you ever had a client, or when you were in industry, do what you just said ever?
Yes, in projects where I have kind of sole control requirements. I'm not saying that you do absolutely nothing until requirements are done. I'm saying that you don't stop working on requirements if there is clearly more to be done on requirements. Like, absolutely, effort can happen in parallel. People can start developing an initial requirement, but if there's one person on the project like me, I will work on requirements until I do not know enough to go further. Some unknown that I need to answer by having a prototype or by having some level of completion of the device. So I'm absolutely not saying everyone hold off until we have all the requirements. That's a good question. I'm not saying that. What I am saying is people, often you have a team where one person is, maybe the lead, maybe a technical lead is working on requirements, and they can go ahead and start groundwork and implementing. But the person who's working on to focus on that and actually finish that effort as much as is practical.
Requirement
does that make sense? Does that answer your question?
It sounds as though you're saying just requirement person, go ahead and give Jeff as much as you can, and then don't take a vacation. Keep working while he's working. Don't be like, I got that taken care of, I'll work on something else.
Absolutely. And again, after I'm done, I'd really love to hear from people from their experience, and maybe some people are nodding their head vigorously and maybe some people are shaking their head vigorously. And so I'd really love to hear from both.
No, we have a talkative block. They'll pipe in as soon as they have something.
Awesome. Okay, another point I want to bring up is that software-specific risk analysis is often neglected. And I have very rarely seen a correct software risk analysis. I usually see a system risk analysis, and it will have line items in it that say something like, a risk is that the software might set this heater output too high, and say you're some temperature control or something, and you're putting energy into the vent, and a risk is that the software has a mistake and it will harm the patient in this way. And the mitigation for that risk is often just like design reviews or code reviews. And I really don't like that. It is much more important, I think, this is why I advocate really pushing through requirements early, is because requirements enable you to do the risk analysis. And then the risk analysis may uncover risks that shouldn't be managed in software, that should actually be managed in hardware. And then that affects hardware requirements. And as we all know, hardware is harder than software. It takes longer. The iteration times are much lower. So you can't find out about those things late. You need to find out about those things early. And this is from IR 8002-1, which is a technical information report about applying the risk management standard 1497 software. And I like this quote: if software is not carefully considered from a risk management perspective early in the product development process, hardware decisions may be made that inadvertently place excessive reliance on proper software operation for the safety of the medical device. Some types of risk control measures are easy to implement early in design and impossible or very costly to implement later. So these are the types of things of putting, knowing early that you can put in hardware boundaries to protect your software. That kind of thing. If you don't do that, then you may find yourself in a Class C software development effort that is not necessary. And, I see software is often used as a risk mitigation for hardware failures, very appropriately so. Software need, and the best mitigation for software failures is hardware features, hardware limits and checks at the software boundaries. If that's not feasible because of the complexity of operation, and it's redundant software on multiple processors that have diverse code, and they're checking each, and only as a last resort do you lean on your software development process as a primary risk mitigation. Joe, I'm getting internet connection unstable. Is my audio still good?
It's been a little unstable throughout, but
okay. Yeah, I'm hardwired, but it's apparently it's just not reliable. Oh well. Pressing on. All right, so I'm going to talk a little bit about the A word, Agile. And so a mistake that I see project and product managers make is not really prioritizing. They say they do, they think they are, and it always comes down to, well, no, we really need all of those things, and can you do this and can you do that? And so a long time, I mentioned at the beginning of the call that Michelle hates Agile, and forgive me for putting words in your mouth, Michelle, but you and I had a conversation quite a long time ago now where I remember you reacting strongly to me mentioning Agile practices in software development. And I have a feeling that's because software developers used Agile as an excuse to not actually do the work, to not specify the requirement to a good level of detail. They said, oh, we'll figure out later, we're Agile. And that's not acceptable when you're developing a medical device. So the way I think you do it correctly is you really define that true minimum set of features. You can think of them as user stories, whatever, that's acceptable to ship a project. Maybe it's not desirable, but it's acceptable. Really, really prioritize those ruthlessly. And then full set of requirements, do what I said before, where you really think through in detail and think of all the implications and all of the error codes and all of the making that work, design, and then start building that. Joe, what's up?
Is he putting words in your mouth, or?
He's not, and he's exactly right. What some of my problem is with it, because I've never seen a useful document for a submission come out of an Agile process. And so he feels my pain. He's seen it, but he also knows how to do it right, and to where you get not only the requirements documented at the appropriate level of detail when it needs to be done, but also understands that, despite Agile, at some point, a document has to come out of it that you can put in a submission to the FDA.
Absolutely.
And I think you said there's no Agile printout that's suitable to attach as an appendix.
Say that again, Joe, sorry?
I believe she said that there's nothing that you can produce out of Agile that you can just download, print, or whatever, and attach to a submission. Is that what you said, Michelle?
No, I don't think so. Is she still on?
No, I'm just like the Agile process in and of itself does not naturally, it's anti-documentation. software developers in general are anti-documentation, which also means that they circumvent certain standard operating procedures, certain flows that they should go through, certain disciplines to shortcut the process. And that thought process in and of itself does, at some point, I have to have a document to put in a submission that is laid out and formatted in a way that the FDA can read and understand it. And so all I'm saying is that Agile does not naturally lend itself to that unless you as a software developer have the discipline, which is what Jeff is encouraging here.
I guess you're saying that the users of the system are not typically using it as completely as they could. So that's more of a user thing than a system.
Correctly. Yeah, not completely, but correctly.
Okay. Counterintuitive to me, I would think, Jeff, that coders are assiduous in showing exactly how they got from A to B. No?
Oh, Joe.
Poor ignorant Joe. I'm just gonna.
Is there an A or a B? Or are we going from B to A? Is there a Z between A and B?
So I'm not going to, I don't want to throw my fellow software developers under the bus too much. I mean, we are a diverse group, and we have undisciplined members and we have disciplined members. And I like to include myself among the disciplined members that give the larger organization that's trying to get this product to market what they need. And there are many others like me who are very good at what they do and are true professionals and are disciplined, but it is the fact that I think
higher Jeff. Got it. Let's
blah 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 blah. Yeah. All right. Okay, so I mentioned this before, basically that you can't use Agile as a crutch to avoid doing work. And I mentioned this earlier in the slide. Recognize when you genuinely don't have enough information, at which point it is a useful thing to make a version of the product and get feedback on it in some form, whether it's a prototype and you get informal feedback, or you actually have your minimum viable product done and you can release it and get feedback from it in use in the field, in a clinical setting. Either way, sometimes you just don't have enough information to make a decision and you need feedback. Sometimes you do have enough information and you're just being lazy. So don't do that. I certainly made that mistake earlier in my career. I like to think that I avoid that mistake nowadays. And it's just, it's an important part of it. Okay. And I've basically been over this already. More details in your requirements up front give you a better estimate of the project effort. They give you a better way to track the status of the project as it's proceeding. And like I said before, it can lead to new information about hardware requirements that, again, because hardware, the iteration time is so much longer, Agile doesn't really apply to hardware very well. It much more applies to software because software has quick iteration times, hardware has long iteration times. You need to know if there are hardware requirements to mitigate software risks early. And so all of that should be done as soon as is reasonable. That flows right into
Rick, did you want to add something? Rick cannot be heard.
There's often a little delay when you promote someone, so let me see.
There we go. It also helps if I unmute. But no, Jeff, I was just wondering if I know product designers can be a lot this way too, as far as being anti-documenting things enough. And I'm wondering, do we tend to be worse or better than coders at ignoring and walking right past documentation?
I don't know. I like I said, I've seen.
I won't be offended.
Rick, is your arm in a sling?
It is.
Oh no.
Yeah, repairs.
I think we all start to break down at some point.
Yeah, mountain biking is not risk-free. Let's just say that.
Really?
Yeah.
All right. Sorry about that. Sounds like an owie.
At least you've still got one good arm.
Yes. Yeah, doing all this stuff one-handed is fun. So
I bet.
Yeah, especially designing. But so what do you think? What's your experience on that?
I think I would say just in general, software engineers tend to be the worst documenters. Maybe it's simply because it's highlighted more by the fact that um, we tend to have a greater number of requirements that we have to, like the software requirement document tends to be longer. In this, and so it, like, as a result, like all the test cases and stuff kind of line with that. And for people who are doing hardware, especially like on the V&V side, those are kind of determined by 60601 testing plans, more constraints that kind of keep you from getting outside the bounds. Whereas I think software is so much more free and running in a hayfield, that people often do get away with really poor documentation, and then they don't happen to get quizzed on that during a 510K submission, and then that's acceptable. As a group, software engineers are worse.
That makes sense. And even when we're terrible about it, we usually have emails or file sets that we have to send off. So even if we're terrible at keeping records, we can always go back and find that bunch of files. So we're right. Sort of limited and constrained by that, the hardware revision cycle.
Right. I will say I have often not seen kind of an engine, like in any hardware design, especially something electromechanical, where it's really a more complicated electromechanical system. I often don't see a design document that kind of says, well, we thought about doing this way and rejected that approach, and thought about doing and decided on this for these reasons, like really clearly laid out. I often don't, and maybe it's just more of a project management fault, where there's not a good central place for those documents where people can access them. They're hidden behind the quality system where only like 2 people have access to it, and it's I don't know, but
no, we're terrible at it.
Fair enough.
Jose wrote something that was funny enough. I could have read it, but it was just too good. Would you share what you typed?
No, I just said that Jeff was talking my product development love language. And just so happens coincidentally that this week I was starting to write a piece on how to use Agile, and one of the things that you mentioned, the minimum viable product, is not necessarily an Agile concept, but a lean startup concept. And I'm a huge believer in that philosophy as well. One of my partners used to work with Steve Blank. But those Agile, lean startup philosophy and medical device product development, at first blush, don't seem like they're compatible, but I'm actually a strong believer that they are. And and there's things that you can do in your process to make them compatible and make them work well together. Like as an example, for us, when we don't do this as much with firmware, but we do this quite a bit with app development and cloud, is we have dedicated business analysts that flesh out requirements in very good detail. And that's particularly important when you're doing very UI-based stuff, because engineers are not usually very good at doing UI. So you want to have UI designers, and you want to have business analysts that really lay out how the thing's going to work in a way that's useful. And then the developer can just focus on implementing that. So you've got a business analyst doing requirements, you've got a developer writing code, and then you've got a QA test engineer who's testing that code. And we use Jira, which is kind of the industry standard outside of the medical device space, to track all that and have good small loops within that. And then the nice thing when you do that is that you take all of those Jira issues, if they're well defined, each particular feature or sprint, whatever, and that can become part of your documentation. So you can then export all of this stuff that you've generated and put it in a format where somebody like Michelle would look at it and be happy with it. But it flows right into the Agile process. So I'm a strong believer that Agile and medical device software development can be compatible. You just have to be thoughtful about how you implement your process. So
I'd like to absolutely do a quick commercial for what we're doing here in Premium, and that is, now I know Jose's marketing guy intimately well, and you've been producing content and sharing on LinkedIn, and that's great. But do you remember, I think it was just 1.5 years ago, when you were my 10X Fast Round guest? And as is the way I typically prepare, I prepared nothing so that you could explain to me what you did. And I needed all 5 minutes to kind of get it. And then, I have to process the videos, and I was like, yeah, he does something kind of mobile-y, IoT something. Just from not only the presentation that you did for us, but continuously just hearing you like respond to Jeff the way you do, I'm like, God, this guy really knows what he's doing. And the reason I say that is I have, you know, the thing that kicked off a grave depression for me back in 2016, 17 was having a client like you that was in product development. And they were like, Joe, how can you get us more clients? And I was like, this is a cult of personality business. There's no one who's going to Google, you know, well, there are, I suppose, but it's not going to be, how do I choose an engineer? How do I choose a development firm? And they're just going to find something. They have to trust the guy and hear the guy or gal and understand that they know what they're doing. And they're like, well, how do you do that? I'm like, well, you have to talk. And it was like, oh yeah, okay. And he never talked. And I was just completely flatfoot. And I was like, how good a marketer am I? I made a nice website for him and his phone's not ringing. But you've really driven home, like if it's wireless, mobile, medical device, you're using all these terms that go way over my head. That's what I want. Mm-hmm. So that someone else who's smarter than I am in that particular discipline is like, go talk to him, and then you can talk their language, and I can be confident that I'm not like wasting my political goodwill and saying, go talk to this guy and then look stupid. So thank you for that. And thank you really all of you for participating in this platform, because it helps me when someone says, hey, Joe, do you know someone who? And I get that question just about daily. York, bringing you to the screen, you wrote something too that I think complements what we were saying pretty nicely. And
hey, York.
I didn't hear what you said, sorry.
I just said that I see your comment and I'm inviting you to share.
Yeah, I think what you hit on, Jeff, is really the key and Michelle is the discipline. You know, there's been in my career, I hate to admit how long it's been, and I've seen, you know, many different popular process models, you know, stage gate and all kinds of other things that were the process of the day. And the bottom line is, it's the discipline that matters. I mean, all the processes can work. And so Agile, I agree with you. Agile is, you know, everyone likes it because it kind of matches the short attention spans that we all live in. And that's great. But again, it's about discipline, and it will work fine and it will work well. But there are also other processes that will work just as well if you apply the proper discipline.
Jeff, you said, you know, the spectrum of people that you can hire vary. You'd like to think of yourself at the 2 standard deviations from the mean pool of folks on whom we can rely. Is there a common thread or discipline among those that tend to be better? Like, silly, I could say they all went to MIT. That's not going to be the answer. Is there some common thing that someone watching this could say, okay, these are the kinds of things I need to look for, and then I'll know that they have the discipline to do it properly the way York suggests?
It is a hard, unsolved problem to evaluate technical people, especially by non-technical evaluators. Just hiring in general is hard. I will say, if someone is junior, then it's even harder. If someone is senior, they need to be able to talk somewhat intelligently about about all of the trappings that surround the code in medical devices. So when you're writing software for medical devices, you know, if you're spending 95% of your time writing code, that's not actually a good thing. It sounds very productive, and you may be a fantastic prototyper. And I know people who are like that, who, if I need a prototype, they are the person that's the person that I go to, because he or she is so fast at getting a prototype. But I do not trust that person to hand me a completed medical device that's to the standard that of quality that is required. So when you're talking to them, if they just focus on the code and they know just the code really well, but they don't even speak to quality and standards and processes, then that's a red flag.
I brought that up last time you spoke.
Did I? Okay.
Yeah, you said that one of the things that sets you apart a bit is that there are basically three groups, and you have to really work as a unit as opposed to just I know code. Jose, you're not.
I see.
Yeah. Because I think, what Jeff's talking about. So Jeff's kind of a rare breed, right? Like he's the kind of guy that's worth their weight in gold because he can do all of those, because he can code well and document and communicate. There's guys who can document who can't explain something verbally. If you rely strictly on finding those kinds of people, you're gonna have a really hard time building a business if that's part of what you're doing, right? And so whenever you find people like that, you grab them as fast as you can. But when you can't find an entire team on that, then it becomes a team effort, right? Where you've got one person, that's kind of what I was talking about when you've got a business analyst and developer QA person, where you've got one person who's really good at coding but isn't really good at documenting, but you've got a really good software architect on the team who can put together, an architecture or software design specification, that sort of thing. And then the coder is looking at that and coding, right? And then you've got a QA person who's testing against that. So when you can find people who can do all of those, absolutely. But if it's not to say that you can't, but it's hard to build an entire team just of those people. And so another way to do it is to have a team of people who have, skill sets that complement each other.
I don't think Jeff much better than if you can find someone like Jeff who's worth his weight in gold as a testimonial. So there you go, folks.
It's true.
Thank you. I appreciate that.
What Jeff said too about the complexity of the products too. We have people say, well, we don't have, on different types of projects, well, we don't have requirements for them. It's just like we just develop it. It's like if you have a really, really simple product that one person can talk to the other person and decide what it's supposed to be and everything that it's supposed to do, then great. But you do have requirements. You just don't have them documented, which is a problem. And as the projects get bigger and bigger, you have these different teams. And if you have someone like Jeff at the center that can see all of the pieces, in the absence of that, your requirements become that because they're written in a way that everybody can understand it. So as long as the software team is developing based on those requirements and does their job well, and the hardware people are looking at those requirements and developing exactly what they need to do based on that, it's like the communication between all of those groups and the design team. It happens through that funnel. So everything, as long as they're aligned with the requirements, then the whole project will work together.
And I think it's like, so what Jose, that's a really good point. I think what Jose spoke to is that you have to have that that good culture at your company. So York's company, Omnica, Jose's company, Bold Type, they have large teams, but everyone is on board. And a place where I often see the real difficulty is projects that sort of spring into existence and you bring in a bunch of contractors. That can work very well. It's just, it's harder for the person pulling that team together. They just don't have a lot of time to iterate on the culture. Like if they happen to choose a wrong person, that will poison that project. And so I don't have a magic bullet for that. It's, the more people, if you're one of those people who will pull a team together and do a project, the more people and who you've worked with in the past, and that they have those skill sets, that's great. If you're building a company like Jose or York, then you're doing it slowly and iteratively, and you make mistakes and you correct those mistakes, and over time you build this organization that's extremely capable, that has all of those, even if all of those skills don't exist in any one member, they exist in the team, and the management of that team is guiding and directing and building that culture. So
if there's a question here from James Burnett, and James, coming on camera is a privilege for members, but I'm happy to read your question, which is there a standard PDR and CDR process for software medical devices? And for me, tell me what those acronyms mean. Also, setting requirements up front is key to reaching design goals. So PDR and CDR processes, is there a standard?
I'm not sure what those acronyms are referring to. Okay. Product development requirements? I actually don't know. Anyone else know?
Yeah, it's probably the product.
And there's PRD, product requirements document.
Okay.
Yeah, PRD.
Yeah, and I'm CDR. James, if you want to just follow up, and why don't we go to the next slide while you do that? Preliminary design review and critical design review.
Okay, sure. So he's asking, are there standardized processes for those?
Yes. Is there a standard process for software development medical device?
The standard process that people follow, like the standard is IEC 62304, and that describes the software development and maintenance lifecycle. And that includes in it statements like thou shalt do design reviews. It does not prescribe how to do those design reviews. So if he's asking for a detailed process of how to do the actual reviews and what the purpose of a review is to make sure that, if you have just done a task, which is writing a software requirements document, and it needs to be derived from a system level requirements document, then you do a review of it with all the people who know anything about it, and go through each line item and make sure they all trace back as appropriate, or not. Maybe they are just appropriate to that level, but whatever, you review it. I don't know if I don't know if I can give any more information about a process for conducting that review, but just that you must do them, and you must do them carefully and methodically. That's all I can say.
Carry on.
Okay, so and I'm really curious to hear people's thoughts on this one. So I like to really draw a hard line between prototyping and development. And the problem is, if you don't know what product you're building, you can, but it's a mistake to do the full design controls process. Prototype first, figure out what your device is, and those prototypes can be electromechanical. People do 3D printing for mechanical parts. I'm sure Rick does this, all the time. You can use off-the-shelf electronics boards and very quick and dirty means of developing software to get a prototype in the hands of someone who's going to give you feedback and do that rapid design. The going through the full design and controls process too early is a mistake. You still need to document that prototyping process in the sense of, we're trying this, here's the feedback we got. Now we're going to try this, here's the feedback we got. But prototyping in the middle of a controlled development effort, or rather starting a controlled development effort when you don't really know what you're building, is I think a mistake, and will lead to a longer development time in the long term. At the same time, once you've if you actually feel like you have this design control development process, and you're using that design control development process to prototype, you're like writing out requirements for your prototype and then doing detailed design documents for them and doing reviews of those. You're constantly kind of going in this loop where, oh, that didn't work, now we got to start this whole heavyweight process over. That's also a mistake. So I want to, people often do that under the guise of Agile, and I really want to draw a hard separation between those two. So the purpose of prototyping is to determine feasibility, to get user feedback. It's okay to have little regard for safety. It's okay for the solution to be half-baked. And that feedback is typically informal. You're never going to use a prototype in a clinical setting. You may actually have some, engage with a usability consultant and actually run usability studies, more formal not, but prototyping is fast and you don't have to follow the process nearly as well. Whereas Agile development, you're like I said before, you're determining that MVP, you're implementing user stories in priority order, but every implementation is fully baked. Those requirements are fully specified. They have all the risk analysis. You really wrap a bow on it and say, at least as far as this feature is, it's ready to ship, it's ready to go. And as soon as you can, get the entire device to a shippable state. So that's kind of the difference there. What's up, Joe?
James Burnett writes again, can you give an example of how hardware can be used to mitigate software risk and vice versa?
So hardware can be used. So a software risk would be that an algorithm in the software allows a heater to heat the patient's skin or something up to too high a temperature. That would be a harm if they burn the patient. So that's a risk that the software does that. And so a hardware mitigation for that is to actually, put in electronic components that clamp the output to safe levels. And you might do testing where you say, if the current to this heater is capped at this level, even under the worst case, there's a lot of feedback all of a sudden.
Yeah, it's Jeff Levine, you can't trust him.
If the current heater is limited to this level, you're not going to burn the patient. The temperature is not going to rise beyond 50 degrees Celsius. That's an example of hardware mitigating a software risk. So at that point, your software doesn't have to be a class C development effort. It can be a class B development effort, because even if the software goes completely wild and turns on, like sends full power all the time to the heater, you're not going to burn the patient. So that hardware has mitigated the software risk. That's what I was talking about before. So go ahead.
I was just going to say, Mr. Burnett, it's the holiday season. I was feeling generous.
Thank you.
Did Jeff adequately address your point, or did you have a follow-up?
It did. I mean, the reason for the question is we start with requirements with everything we do. It's almost a non-segue if we don't get requirements. We supply the sub-assemblies that are integrated into medical devices. So the software interface is normally handled by the medical device company, not us. But the point that you raised about, and the question I'll start asking our clients here is there something we can do to mitigate risk here with your system? Because we cool lasers, we cool the skin, we cool a number of different things with our applications. And there's an interface there that we've historically sort of been blind to, but I think there's a lot that we could offer there where the question hasn't even come up in terms of what we can build into the hardware to make the product safer, better, able to absorb a wider range of conditions or whatever that might be. And so I found that compelling and interesting for the piece that we bring. But set in the requirements at the beginning for software, it's every program, and every program that we do, we ask for that. And because otherwise, what is it that we're going to have to make here in the end and deliver and certify? But
it sounds like
an introduction to make shortly after this call between you two.
Yeah, I'd love to talk more about that. And it sounds like, James, that you're working on devices that are much higher on the complexity scale. If you were an entire company providing a subassembly and cooling lasers, it sounds like that's a relatively complex device. Because I am a solo operator and there's only so much one person can do, I tend to work on devices that are much lower on the complexity scale. You know, think surgical tools or, you know, point of care treatment devices, that kind of thing. Yep. But in either case, whether it's more important for complex devices like you, that there is someone who is truly a systems engineer, not from a documentation point of view, but from a technical point of view, who has a moderately deep understanding of all of the different engineering disciplines and can really see the problems and point out. And they would be the type of person who would say, we're requesting this outside group to give us the subassembly. They need to, you know, like if they did it this way, they could control the risk in this other component. And there's no magic bullet for that. It just someone has to be able to see those connections. So
Jeff Levine, who shortly was floating above the San Francisco Golden Gate Bridge, asks, how does that level of documentation change when the prototype is used in the OR to collect data, operating room to collect data?
I do not know. I have never been involved in such an effort. To me, so at that point, I would say you're starting to blur the lines of what is a prototype. If it's actually capable of being used on a patient, even if it's a one-off, like it's maybe not manufactured, it's like a hand-built thing that like $500,000 went into this one device, and we're going to use it in the OR. A full design controlled effort needed to go into producing that prototype. Yeah. If you're using it on a patient, it needs that process. When I refer to prototypes, I'm talking about, you know, thrown together things that are to demonstrate, say, to a doctor, we're thinking this would work. What do you think about that? So if something's to the level of being used on a patient, I think it needs that much more rigorous process behind it. But I've never been involved in such an effort. That's interesting.
Well, I'm glad to be breaking barriers.
By floating the way you are?
Say that again?
By floating above the skyline the way you are?
I can't see myself. I wasn't planning on being public at the moment.
I can see you on a handheld because we're getting a lot of this.
All right.
Sorry, I'll try and stand still. I'm out walking my dog.
Oh, nice.
So our product is kind of somewhere the way you describe it, in that middle ground, where we are using it in the operating room to collect data. So no decisions are making it. It's not affecting the standard of care.
So it's more of a measurement device.
Exactly. Yeah, it's a scanner.
Okay.
So we're collecting data and then we go home and analyze it.
So the risk of that is correspondingly lower, unless it's like an active scanner where you're actually, it's an X-ray or something, you're pumping energy into the patient. If it's purely passively, if it's purely passively monitoring, then that can be a thrown together prototype because there's no risk. So yeah, you can hack that together all you want.
Nervous for a second. All right, thanks. We're not quite hacked together.
It's all risk based. If you can hurt someone, you need to mitigate that. If you can't hurt someone, take data to your heart's content.
Very good. Thank you.
The only risk would be that you're mucking with the surgeon's capability of successfully performing a surgery. So that risk you need to mitigate.
And we do, and that's something addressed in the protocol and non-significant risk documents and
perfect
and so on. So thanks. I'll check out, but learning a lot today. Appreciate it.
Good. I'm glad.
I personally think that, and I bet I represent most folks on the call, we would be far more interested in the surroundings of your neighborhood walking your dog than that static image that makes you float like that.
All right. Well, let's see if I can
Jose,
go to none.
And all I was going to say is that, we run into this quite a bit, and it's sort of somewhere in the middle. I think when you're going to do prototypes that are going to be used in a clinical setting, you want to have some level of controls in place, but they don't have to be the full design controls in place. So you'll want to do something like a DFMEA or some sort of risk analysis, because you might say, well, there's no risk because it's a diagnostic device. Well, how do you know? I mean, what if your diagnostic devices can harm patients? So
we learned long ago that
documented that. And so it's a good record to have. And then, of course, you'll probably have to submit an IRB application, institutional review board review, and they might ask for that kind of documentation. So you don't need to have full document controls or full design controls in place for that, but you'll want to have a good subset of that. And you also want to be able to show that you've built the units with some level of control, right? That you know what's in that device, that, you've got somebody signed off in a bill of materials, that the thing that you built, what's in there. But
you're exactly right.
Between
we looked at all those things. Yeah, we have a couple of approved IRBs now, and we did have to do all those things you mentioned.
Yep.
Jen?
Oh, I was just saying I agree, because you have to make sure you don't hurt your patient, whether it's product, something coming out of your device that could harm the patient, or microbes, or anything that could interfere with nurses and doctors that are working with a patient. So as long as you're doing your risk controls properly, I guess it works.
Yeah.
I wouldn't want it in the hospital room with me during surgery, though.
if it has not gone through that process, right?
Were you able to connect with Jonathan, Jan?
Excuse me?
Were you able to connect with Jonathan, who saw a packaging?
No, we tried twice. He didn't show up. So.
Come on, man. I think he's up, or he was on the call. Anyhow, Jeff, back to you.
So this is great. So I've learned something that I need to be careful with this terminology of prototyping. I really brought it from my world where, a prototype is, again, not used on people, whereas it sounds like there is a definite middle ground of, whether they're prototypes or pre-production devices or whatever, they are actually used on people. And so that needs to split the difference. And you just have to, in the end, all comes down to risk, and you have to mitigate it. So I really appreciate the discussion. So we're still nominally talking about software. And I will say that software prototyping can happen in the middle of product development. Again, to explore a hypothesis, to learn something, you need to implement just enough of a feature to get it in the hands of someone who's going to give you feedback on it. The biggest mistake I see is people say, like, we go through this very quick prototyping effort, we have code, it looks like it works, and we say, great, we're done. Like, you're ready to continue, right? No, like, that code is garbage. Throw it away. You have to do the full design control process. You learn from it, but it's not actually useful in a production sense any more than a quick 3D printed prototype is actually, you learn things from it in terms of the shape. and how it might function, but it is not the final product, and code is no different. So that's a place where there's this harmony between hardware and software. Both disciplines prototype, and in both disciplines you need to throw that prototype away. You can have it sitting on your desk while you're doing the real version and use it for inspiration and use it for lessons learned. That's great, but don't use it, and don't be fooled into thinking that just because this prototype code works, that you're where you need to be. Okay, so zooming back out, we're still talking about software engineers interfacing with product and project managers, with members of the management team. And this next one, I'm going to browbeat people to start using modern tooling. I see it often where the software team wants to use something that is basically industry standard in the software world, and medical devices is always lagging 10 years behind. And they want to pull in these modern tools and basically get shut down of either we have a heavyweight validation process and we can't do it, or that's just not the way, that's not appropriate for medical. Whether you say you're doing an agile process or a waterfall process or any hybrid in between, requirements will change over the course of development, as much as you try to spend time up front specifying them. And I'm not saying that I'm not in favor of detailed requirements up front. I absolutely am. According to the first part of the presentation, you will still learn things during the development. You will overlook things, and requirements, it's guaranteed to happen that they will change. So you need to make it easy for them to change. And if you add a lot of friction to that process by using legacy tooling, it's just going to slow your project down. And so it is worth investment in using modern tools. And this is why I'm really, really against using Word and Excel for tracking requirements and test cases. The advantage of those things is it's very easy to get started. You just open it up and you start writing. The problem comes on the back end when you have 6 layers of requirements documents, or 6 different requirements documents rather, from the product, maybe a couple of subsystems, maybe several different software requirements that are detailing different software subsystems. And then you have test cases on the back end that are verifying that the device actually conforms to each one of those requirements. And you make a change and you have to manually go through and change it in 7 different documents. And it's even worse it's the worst when you're emailing versions of these Word documents around the office. You don't have a central source of truth. That's really atrocious. But even I've seen Word documents kept in Dropbox or one of the other cloud storage services like that, where it nominally makes it easy to collaborate. The problem is if you're collaborating among 5 or 6 people and even they're touching different parts of the document, it's just so painful. And the task is relatively simple. Like, oh, this requirement needs to change, and therefore we need to make sure that the test case gets updated. And it needs to be obvious to us that this requirement changed, therefore a test case needs to be updated. And you just, like, I've been in companies where it literally takes 2 or 3 people an hour to do that task that should take me 10 seconds. And that kind of thing compounds and compounds and compounds, and it's so painful. So when I say modern tools, I'm talking about things like JAMA, things like Greenlight Guru. Jose mentioned that they use Jira. I haven't played with it, but I've heard that there's a plugin for Jira called Zephyr that does really good management of test cases on the back end. I haven't tried it myself, but I've heard really good thing about Matrix lifecycle management. So I'm not at all trying to be a commercial for any of these tools. And I will say, none of these tools are perfect, and you will start using them and you will be annoyed and you will want to go back to Microsoft Word because, oh, I just want to write this damn thing. And what I'm pleading with you is invest the time to use these tools in a system that works well for you. And if you have to write custom scripts on top of them, so be it. But this is a path that will lead to pain and friction and a long development process. And you absolutely need to be tracking your requirements and your test cases in tools that are designed for that.
Jan, you had something to add? You cannot be heard.
I was just making a comment that I wish he could go talk to the government where one of my kids works, because they definitely need help with this kind of stuff. I mean, you're talking days to change stuff because you're still using code from 20 years ago, and it seems like a nightmare. So I'm glad medical devices are a little farther along, but
yeah, I think 20-year-old people still writing bank software in COBOL and stuff like that. It's but I will say that the medical devices may be ahead of that, but that's a pretty low bar. We are way behind other industries in terms of having, and all of this really comes down to, this affects software quality. If you introduce a lot of friction into doing the right thing, then engineers who don't have certainly high levels of discipline will not do the right thing. So you have to make it easy to do the right thing, and that's how you get quality software.
So how do we get the government to think this? Because they're writing code for missile guidance systems and stuff, and this is scaring me.
They just do it. I'm not going to give you a good answer for how to get the government to do something. I know people who work in aerospace, and I think it just costs more. So that's why those programs cost. That's one of the reasons why those types of programs cost a lot. Is that the tools are hard, and the process is just very, very burdensome because of that. But people go through the burdensome process, and the developers who like to have fun tend to stay away from those places, and the people who are in there are ones that can really like handle that level of burden. And hats off to them. People look at me in the medical device industry and say, how can you handle that level of burden? I'm like, I don't know. It's not so bad. So I'm sure they're kind of have that same attitude about it. So.
Well, and the other comment I had with prototyping and stuff, in my field, when I find something in a prototype that works almost right, or I just throw it away or something, I still have to document it to say why I didn't want to do that.
Right.
And you just said throw it away and not worry about it anymore.
I meant in terms of, you're absolutely right in terms of documenting it, and it depends. I mean, I've certainly, if you didn't make the prototype and you knew what the right thing to do was first, and you just wrote requirements and went through the process, and because you're a very experienced forward-thinking engineer, you can kind of see a lot of problems coming, and you make all the right design choices first. Does that suffer from not having prototypes to point to? Does that make sense? I'm kind of posing a hypothetical.
Yeah, it doesn't hurt where you are as an engineer, but because of the way the auditors work, they want to see that trail.
They know that it's impossible to get all the design choices right the first time, so that will be red flags to them. If you just say, "Oh, we just picked this perfect design and built it," they'll say, "No, you didn't. No one does that."
Yes.
Okay. Yeah, that's a very good point. Yeah, in terms of throwing it away, what I meant was, don't use the result, but document and use the learnings. That's what I really meant by that.
Just wanted to make sure.
Absolutely.
And much as I said for Jose before, just talking with you and hearing you feel these things, it's clear that you know what you're talking about. So thank you for sharing that. Moving on.
So in terms of, so I was talking about using more modern tools, and where you really want to get to is where most of the busy work is automated away. And by that, I mean, you have so Michelle says, like, I'm preparing your submission and I'm talking to the FDA, and you have got to give me documents that are formatted in the right way. You cannot give me a printout from JIRA that's formatted like crap, because no FDA inspector is going, or contact at the FDA is going to approve such a thing. So that takes work on our side to take this lifecycle management system that's backed by a database that's tracking all requirements, that handles things automatically, and we have to generate our documents from that. It's hard. Some tools support it really well, some tools don't support it really well, and that I would put that as a requirement to the tool selection of somehow you should come up with a process to generate the requirements documents, the risk analysis documents, the test reports, and the trace matrix. I should be able to make a change, like change a requirement, update the test case, press a button, and I get a new version of all of those documents that is reflective of the latest state of the system. That's the ideal. I have seen very few companies get to that ideal, but that's the ideal. So I'll give a shout out to a company that I've interacted with recently. There's a company called Blue Fruit Software. They're based in the UK. Paul Massey's their founder. And he gave a webinar a few weeks ago where he talked about living documentation. And it was exactly this. It was about generating documentation automatically during the course of development, where it's all of that busy work is taken care of for you. And it just unlocks, it just eliminates friction and just much more rapid development because you just take away the burden from that process. You can generate your detailed design documents from comments and documentation files that live with the source code, that are checked into the same version control repository as the source code. And that's one of the ways that you keep your design documentation and your code in sync. If your design documentation is in a Word document and your code is in code, every time you make a change to the code, you have to go back up and change the design document often, at a certain level. And that's just a classic problem, that those two are never in sync. And so if to as much a degree as is practical, generating it from the source code and from comments in the code, and maybe from, simple text files that are checked in with the code, that's what you want to be able to do. And then in terms of my development, I practice test-driven development. I practice continuous integration. These terms, you may be familiar with them, maybe they're Greek to you, but those are, continuous integration is the process where you automate a software release from the act of checking a version of code into version control. And a build server takes care of all of the steps in that process for you, building the code for both the device and maybe for your, building it for your PC so you can run unit tests on it. You can automate loading it onto the device, a test version, and running integration or subsystem tests on the device. You can do static analysis, lots of different things you can do, and you automate them all. And all I have to do is make a change, check it in, and all of those processes happen automatically. And there's feedback right to me saying it failed or it passed. And that just gives me, the developer, that much more confidence that what I did has the right level of quality. And so I'll say that even for small projects, even for projects that are not Agile at all, that are truly waterfall, investing in that level of automation, even if it's a waterfall project, you have this long development process. Having that automation running makes sure that you come out of that with your documentation all up to date and ready to go, and you don't have to go back constantly and fix things. And I hear a lot of companies saying, we can't use that tool because our IT department has this onerous validation process to comply with Part 11, and it's just too much effort to validate the tools. So we're not going to do that. We're going to live with what we have. That drives me absolutely up the wall. It's not an excuse. And it's probably because your company, your organization, has too onerous, too heavyweight of a process to, like a modern version control system like Git. It's used by it was created to develop the Linux kernel, which runs on billions of computers. It works. The risk from using that is very low. The process to validate that so you can use it in your medical device company should take less than a day, if that. So you got to fix your broken validation process. If you're part of a large company where there's a lot of bureaucracy and a lot of stakeholders and people to convince, I feel for you. There again, I don't have a silver bullet for that. Maybe go read How to Win Friends and Influence People and apply those lessons. But it's if you're the one in charge of this and you're the one saying we can't use these software tools from other industries because they just don't work for medical, then you're the problem, and stop it. Come talk to me. Okay, so reviewing kind of the different items that I touched on. So I talked about a way to better track development status of software is to visually track the completion of requirements, as well as the tasks that people have decomposed those requirements into. Track them both. That's a good way to see if your goalposts are moving. and understand really why the delays are happening. It may provide some more information for you there. Include software in your risk analysis early. Every discipline likes to say, well, we should be brought in at the very beginning to have input into the design. And really everyone's right. I mean, that's, all the different engineering disciplines, regulatory, quality, people who are evaluating the business case, all of those stakeholders need to be at the table early, and we software need to be there too. And then this particular activity of doing this risk analysis is often neglected, and that's a mistake because the outputs of that feed back into the design and can change your hardware design. You need to prioritize requirements ruthlessly, and then take the requirements that are the most important and think through them rigorously. And often it's just people being lazy and procrastinating and not wanting to go through that tedious effort. And to those people, I say, suck it up. Make sure you're mindful of when you're prototyping versus when you're developing. And you can do that mid-project, but don't be seduced by using the output of a prototyping activity and thinking it was the output of a development activity. It's very seductive, and it's not acceptable. And then please, please, please invest in and support the use of modern tools and automation. And your software developers will love you for it, and you'll be much happier as an organization. So again, just a quick review. Go ahead, Joe.
Oh, no, just I saw the almost done slide, and James, you might want to jot down his email. Please go ahead.
So this is it. So if you have any questions about any of this or need help implementing it, please get in touch. This is my contact information. And again, just kind of the 3 different levels of service I provide. Purely advisory, where I'm just a software expert on demand. And I've done one-off calls with people. I've done monthly retainers where, unlimited calls and emails for kind of a flat monthly fee, and you have full access to my expertise. I've helped software teams improve their processes. I've coached them on continuous integration, test-driven development, agile practices. And if you just need it done for you, and again, like I mentioned before, it's on the lower complexity end of devices, I'm a good resource for that. If it is a IoT device, I'm going to send you to Jose. If it's a very large, complex device, I have other contacts that I can send you to. But that's about it.
Well, ladies and gentlemen, now, like me, you know a guy.
And I was wrong. It's already, I guess I answered a lot of questions during, but it's already 9:20. Oh, well.
Next week, I have a guest. He spoke at 10X, I don't know, maybe 5 years ago now. And he is on a quest to cure aging.
Okay.
And apparently dying from age is the #1 cause of death. So, he was old. It's like, okay, but that's not a condition. And so his work in telomeres and the like is really quite fascinating. So you might want to tune in for that. And I have extended the schedule, to go all the way through next year. But no, even I am not going to have a call on Christmas Day and New Year's Day. So we'll take those 2 weeks off, and I'll see if I can switch off reminders for those. Ladies and gentlemen, my friend, Jeff Gable.
Thanks, everybody.
We'll see you next week.
All right.
Bye for now.